Why do we learn to draw in isometric? Isometrics are quite lifelike, so they are well suited to communicating ideas spatially. They enable you to draw a plan, an elevation, and an end view. A plan, an elevation, and an end view. So broadly, isometric drawings are all made with horizontal lines that are 30 degrees and all vertical lines remain at 90. The simplest way to learn to draw in isometric is by using a piece of trace laid over a 30-degree isometric grid. This gives you enough guidance to make convincing 3D drawings with the reassurance that if you mess it up, you just put another piece over the top and you can redraw. The process of tracing is very freeing and quickly enables you to make advances from simple to more substantial and challenging drawings. Start by drawing a cube, then a couple of cubes, then begin multiplying the cubes like pixels, so that the tiny boxes provide the simple underlying geometry to construct increasingly more subtle forms. This process is known as additive drawing because you add one shape to another and another and another, and you build forms in a modular way. You draw the framework in blue pencil, then pick out the shape in thin pen, then finish the drawing with a thick pen, outlining the whole shape. The next set of drawings you make can combine additive and subtractive sketching. Subtractive sketching, like it suggests, gives you a way of imagining a shape and then taking part of its shape away. So you draw a blue crate, then you refine the drawing to show the shape you want to remove, then you draw the shape that remains. The rule of sketching is that you start from the general and progress to the specific. This enables you to shift the focus of your attention or change a final sketch while you are making it, if a different result drops into your head during the process of sketching. When you draw without a grid, you follow the same procedure of drawing an isometric module in blue pencil to establish 30-degree lines. Then you can begin to develop 3D shapes with a reasonable degree of accuracy. A quick way to introduce scale into your drawing is to introduce figures. This shape has scale, these two shapes, and each of the figures expresses a height. We see the figures and subliminally change the scale of these boxes. Each of these figures represents a human height, which we normally take to be 1.7 meters, which is around that height. So we would infer that this overall structure is maybe twice the size of a human, a little bit over. So if that's 1.7, that's 2 times 1.7, 3.4, it's roughly 3.5 meters tall. The world isn't all square, so we need to be able to draw curves. To construct a curve, you begin from a rectangular crate, which acts as a guide for your hand. If you can make a reasonably convincing crate, you have a good chance of drawing credible curves. This is a good example of isometric drawing being adapted to visualize a proposal, where the engineer is applying a simple additive and reductive isometric technique. The drawings on the left depict one building rotated to show it from 2 different viewpoints. The drawings in the middle show the effect of removing 2 portions of its mass, and the right-hand section shows the building with new structure added. In the top right is the schematic plan, colored to indicate the proposed demolition and construction phases.